Diffusion is the movement of particles along a concentration gradient from an area of high concentration to an area of low concentration. So here's an area of high concentration of a particular particle. So diffusion occurs in any fluids. So that means liquids and gases. It doesn't happen in solids though, because the particles aren't moving around in solids. I mean, they're vibrating in place, but they're not able to move around each other. But in liquids and gases, diffusion occurs. So we have an area here of high concentration. So I'm going to show you that by drawing an arrow up for high, and the symbol we use for concentration is a square bracket. So that's our area of high concentration. On this side, let's just say we've got a few little particles, but certainly it's a much lower concentration. Over a period of time, what's going to happen is the particles are going to be moving overall. Of course, particles are moving around all over the place, but overall there's going to be a net movement of the particles from this area of high concentration towards the area of low concentration. Now, this happens quite a lot in the body, and it actually happens across membranes. So I'm just going to draw in here a membrane. So what's a membrane? A membrane is a thin tissue, and I'm actually going to add something here, and I'm going to call this a semi-permeable membrane. So semi-permeable. Permeable means that it's got some holes in it and it's allowing some things through. Semi-permeable means it allows some things through but not all things. So think of it like your sieve that you use when you're tipping your boiling water with your spaghetti. You tip it through the sieve to get rid of the water and it keeps the spaghetti. So it's permeable to water but not to the spaghetti. So we have plenty of semi-permeable membranes in the body. Now they will allow some things to pass. So if these particles, of whatever they are in the body, there might be glucose or oxygen, if they're able to cross the membrane, then that diffusion will still occur. It will still move from an area of high concentration to an area of low concentration, and it will balance out to the point where we get equilibrium, equal amounts on either side. Okay, so I'm going to show you two examples of how this occurs in the human body. Okay, so the first one is in the digestive system, in the small intestine. In the small intestine, that's where glucose and other nutrients get absorbed into the blood. So in other words, they cross the small intestine wall into blood vessels. So how does that occur? Well, if we had a look microscopically at the surface of the small intestine, it would actually look like this. It has these finger-like projections called villi. And so the small intestine wall is villi. So in here is the small intestine. On this side, we have got the blood vessels that actually go up through the villi. So why do we have these finger-like projections? Well, it increases the surface area of the small intestine so that the diffusion across into the blood happens more quickly. Alright, so we've got a concentration gradient here. We've got a high concentration of glucose molecules in the small intestine. So high concentration in the small intestine, and in the blood there's a low concentration of glucose. So we have a concentration gradient, high in the small intestine, low in the blood. So there's going to be a net movement of glucose particles, molecules, into the blood. I'm going to show you one more example, and this one is in the lung. In fact, it's in the very, very small air sacs of the lungs called the alveolus. So the alveolus are very small air sacs. And so through here, oxygen goes in and carbon dioxide goes out. All right, so this is where we get the gas exchange. And so if oxygen's coming in, that means we have a high concentration of oxygen. We're breathing out the carbon dioxide, so we have a low concentration of carbon dioxide. Now, again, we have gas exchange. So wrapped around each one of these alveoli is a very small blood vessel. It's coming back from the body, so it has got low concentration of oxygen because it's been used up by the body. So we've got a concentration gradient here, haven't we? We've got low oxygen in the blood and high oxygen in the alveolus. So overall, there's going to be a movement of oxygen into the blood. Now, it's the opposite with carbon dioxide, because the blood that's come back from the body actually has a high concentration of CO2, because it's a byproduct of respiration in the body. So there's a whole heap of CO2 coming back. So we've got a concentration gradient again. This time we've got high concentration of CO2 in the blood and a low concentration in the alveolus. So this time there's going to be a net movement of the CO2, the carbon dioxide, into the alveolus, and then that's going to be breathed out, and we're going to repeat the process again. Again, the alveolus there's thousands and thousands of these little air sacs to increase the surface area, and the wall of the alveolus is very, very thin. It's a semi-permeable membrane that allows the transfer of the oxygen and the carbon dioxide through the membrane.